worked with text boxes in our previous programs, including input boxes and dynamic text boxes. And we can think of those as containers. They contain some text. They have a property called text, and that value of that text property can change. Those are visible containers that the user sees. We have another type of container that's an invisible container. It exists in memory and not necessarily on the screen. And those are called variables. And just like the text property of a text box, the value that's contained in those variables can change, thus the name variable. So really all it is, it's a location in memory that contains some value. That's what a variable is. And rather than referring to the variable by the memory address, which would be a string of numbers, which can get really confusing, we refer to the variables by a name that we give them, something meaningful. In order to set up that variable, we have to declare it. And so the declaration statement is preceded in ActionScript by the word var for variable, the name of the variable that we're going to give it, a colon, and the data type. Now you've worked with data types in the past. When you worked with Access in CIS220DC, you set up fields and you assigned different data types to those fields. They might contain text, a field might contain a number, it might contain a date or time, it might contain a Boolean expression, or in Access referred to as a yes/no data type. And there are other data types in Access as well, such as hyperlinks and memos. And those were all set up when we set up a table. The reason we set those data types up was to make our tables more efficient. We didn't want to have this huge field for text or for a memo when it would only contain a number. And so different data types are associated with different sizes of containers. And that's what we're doing when we set up variables in ActionScript. We set up variables of different data types to match a specific size container that will hold that type of value. In Flash, the most common data types are number, string, and Boolean. And then there's also int, which stands for an integer. It's a whole number. It has a range of a minus a little over 2 billion to a positive roughly 2 billion. And then there's an unsigned integer, or uint, which has a range from 0 to a little over 4 billion. A number data type can be either whole or an integer, or it can contain decimal numbers, such as 12.5. String data types are alphanumeric text, and they contain literal strings that may be specified inside of quotes. Person's name, their address, the city they live in would all be examples of strings. And Boolean data types contain a value either true or false. There are some rules for naming variables. They have to start with a letter or an underscore. So the variable here that I have listed in red of today with the number 2 is not a valid variable name. It will give you an error. The Instructor would be okay. There can't be any spaces or special characters such as asterisks or percent signs or carets or dollar signs. So the percent spelled out is okay, but if you use a percent sign, that would not be a valid name. They may contain numerals or underscores, so title 2 is okay, as long as it doesn't start with a number. And you would put an underscore there instead of a space if you wanted to have multiple words. Names are case sensitive, and so last name with a capital N is not the same as last name with a lowercase n. And you cannot use keywords such as int, x, or y. X and y are used for coordinates of an object. Int is a keyword specifying integer. But you can use x, y, or int inside another name, such as interval. Some other suggestions that not all programmers follow, but use meaningful names. When you read your code, if you use a name that's meaningful, which is base elevation, versus B. And those programmers, when they use meaningful names, rather than using underscores between words, will just use camel casing, where variable names should start with a lowercase letter, and then every subsequent word is capitalized with the first letter. So semester, room, and board, where the R, A, and B are uppercase. Once you've declared a variable, you can assign it a value. And the statement there is simply whatever the name of the variable is equals some new value. Now that value has to be of the appropriate data type. So we can use pay rate equals 34.75. That's a numeric data type or number data type. Last name equals Jones. Notice Jones is in quotes, so it's a literal string. Over 18 equals true. Over 18 was a Boolean data type in the previous example. Temperature minus 25, that's an int. And miles flown equals a little over 3 million as an unsigned integer. Can't have a negative value with an unsigned integer. What I can't say are things like pay rate equals Jones. Jones is not a number, and pay rate was declared as a numeric value. If we try to do that, we would get an error. Those two different statements of declaring our variable that you see there in the yellow box and then assigning a value to it in a subsequent statement can all be accomplished in the same statement. This is called an initialization statement. So we can declare a variable and give it an initial value. And the format there is var, the variable name, colon, data type equals value. Oh, and don't forget the semicolon. So here's some examples of taking those two previous slides and combining them. So we have var pay rate number equals 34.75, or var over 18 Boolean equals true. One of the reasons we declare variables is to then use them in calculations. And so it's easier to relate to a variable by a name that is understandable. And so I might have var num1, which is an integer, equals 12, var num2, which is an integer, equals 7, and then var num3 is an integer, and I can assign it the value of num1 plus num2. So in this case, num3 would equal 19, 12 plus 7. In a lot of cases, we're going to take text from a text box, an input box, and assign it to a variable we then use in some calculation or in some concatenation exercise. So I might have a variable called last name, which holds a string value, and I'm going to take the text property from the input box named input underscore txt and assign that to last name. The last statement here, where I have age is a number, I'm going to take the number that somebody enters into a text box named age underscore txt. I'm taking that text property. But remember, that's a string, and I can't assign a string to a number variable. I have to convert it, what we call casting. And I can do that by specifying the data type with parentheses, and inside those parentheses being what I want to cast or what I want to convert. So I'm going to convert this string value that's in age underscore txt to a number, and then I'm going to assign it to my age variable. We'll talk more about casting in a future video. In the next video, we'll look at how to use variables in some calculations.